Welcome. For those who haven't subscribed, please do so. It will be an encouragement for me. For those who have subscribed, I thank you and hope these videos help. I have begun scripting the lecture, so I hope the presentation will be smoother. In this lesson, we will look at measures of variability. When measuring one sample many times, the measurements are never the same. This is especially true in microbiology, where the colony-forming units, or CFU, isolated from the same sample can vary quite strikingly. There are several statistics that you can use to constrain the variability of your data. You can use range from minimum to maximum or interquartile range. For interquartile range, we usually use the first quartile to third quartile or 25th percentile to 75th percentile as boundaries to show variability. To give you an idea about quartiles, second quartile is actually equivalent to median, whereas the fourth quartile is the maximum value. So in Excel, you can obtain these statistics quite easily. Here we have the sample data of log transformed counts from chromocult agar, and to calculate the minimum in Excel, you have to start off with an equal sign, then min. Array is you have to highlight the cells that you want to include, close the bracket, and that is your minimum value from your sample range. For maximum value, it is the same procedure. You type max and you highlight the array, and you have the maximum value here. To get the quartile, this is the equation you should use. The numbers here represents the first quartile and the third quartile. We will do the same procedure. Highlight the cells that you want, then type in the first number for the quartile, first quartile, then and this will be your third quartile. So this is the first quartile and third quartile for this sample data. The variability or variance in your measurements is due to error because of the measured or observed value is not the true value. In order to describe the average amount of dispersion, variance or sum of squares can be calculated according to this equation. So this represents your sample observed value minus the mean. Variance is divided by n minus 1, which actually increases the sample variance relative to population variance. This is of course also related to the degree of freedom, where the mean is fixed, therefore degree of freedom is reduced by 1. Problem is, variance is a squared value, so the value is not the same scale or unit as the original measure. So it is not as frequently reported as the next topic that we will be discussing, which is standard deviation. This standard deviation is the square root of variance and shows how spread out the scores are in a distribution. It is on the same unit as the original measure, and which is why you see it often and widely reported in journals. So this is the equation to calculate for the standard deviation. Data that follows normal distribution, mean plus minus 1 standard deviation, contains 68.3% of the distribution, whereas plus minus 2 standard deviation contains 95.5% of the distribution. A mean plus minus 3 standard deviations contain 99.7% of the distribution. This actually helps the readers appreciate the possible spread of the mean. Now we will look at how we can use Excel to calculate sample variance and sample standard deviation. So for sample variance, you use the following equation. Type in the equal sign first, variance, sample, then highlight the array. For population variance, the S is changed to a P. So this is sample variance. Sample standard deviation, follow the following formula, then highlight the cells that you want, and this gives you the sample standard deviation. Of course, you can also calculate the population standard deviation using the following formula. Standard deviation calculated for one parameter cannot be compared with other parameters that are measured. For comparison of dispersion or variability among different types of measurements, you may use coefficient of variation, or also known as relative standard deviation. This is a standardized measure of dispersion and is especially for ratio scale types. And to calculate coefficient of variation, you divide the standard deviation with mean. Other than coefficient of variation, standardization of your data to z-scores also allows comparison of dispersion among the different variables. So z-score states how far from the mean a value is in standard deviation units. For example, a z-score of 0 is equivalent to the mean, whereas a z-score of 1 is 1 standard deviation, and z-score is calculated by the difference between the value and the mean divided by standard deviation. With Gaussian or normal curve, a z-score of 3 means it is at plus 3 standard deviation. So if you obtain a value that is plus 3 standard deviation, then the area below z is 0.00985. That means the probability of obtaining this value is 0.0015, which is less than the critical p of 0.05. Therefore, the value obtained is highly significant and did not occur by chance. So let us look at how we can calculate coefficient of variation in Excel, and also how to standardize your data to z-scores. So to calculate the coefficient of variation, if you remember the formula, it is the standard deviation divided by the mean. Okay, so this is your coefficient of variation. Coefficient of variation is usually reported as percentage. So this will be 23%. To standardize this data to z-scores, we will have to calculate the mean with the following equation: average the array. Okay, so once we got that, we can type in standardize this cell according to this mean 3.027, and according to the standard deviation, which is 0.712. Okay, then just drag this down, and from here immediately you can see the z-scores in standard deviation units of your sample data. Sometimes when you have repeated your studies and you have several studies each generating a sample mean, you may use standard error of means to show how the sample means actually differ. Standard error of means is the standard deviation of this mean and is calculated by dividing standard deviation with the square root of sample counts. Other than standard error of means, some also use confidence intervals to show the range of true population mean. Usually, a 95% confidence interval is used, where the true value will fall within these boundaries 95% of the time. So to calculate the 95% confidence interval, if sample count is more than 30, we use normal distribution. If sample count is less than 30, we use the t-distribution according to this formula. For example, if sample count is 25 or n equals 25, then the degree of freedom is n minus 1 or 24. As we are looking for two-tailed tests, okay, two-tailed tests, so the p is 0.025 if you're looking at this place. Okay, so two-tailed tests, the t value, the critical t value is 2.0639. Therefore, to calculate the 95% confidence interval for a sample count of 25, the equation is as follows. Here we begin by calculating the standard error of mean using the following equation. So standard deviation divided by the square root of the number of sample data. Okay. Okay. So this is the standard error of means. From here, we can calculate the confidence interval, 95% confidence interval for t-distribution by using the following formula: 0.025 for two-tailed tests, then the standard error here, and the count of, we can always do this to get the count. So this will be your confidence interval at 95%. You have to calculate mean plus 95% CI and also mean minus 95% CI. So this will give you the boundaries where the true value will fall within 95% of the time. Okay, until the next lesson, thank you for your kind attention and please remember to subscribe.